Hello IntelliScientist, welcome to Alan IntelliBrain. In this video, we will acquire the knowledge of forming the two-dimensional nets and three-dimensional models of different type of prism, verifying the Euler's formula and visualizing their front view, top view and side view. From our IntelliSmart box, take out the prism sheets, geometry box, glue and marker. We always see prism-shaped objects in everyday life. They include ice cubes, buns and candy bars. Take out two triangular cutouts, two pentagonal cutouts, 5 orange color rectangular cutouts, 3 red color rectangular cutouts, 1 marker and 1 glue, and then start performing the activity. Let's start the activity by forming the 3D prism model of triangular prism. For that we need 2 triangular cutouts, 2 orange color rectangular cutout and 1 red color rectangular cutout, and marker and the glue. Now we will start folding the rectangular cutouts along these white lines. Similarly, you can fold the other rectangular cutouts along the white line. Now, put the markings on both sides of the triangular cutouts as 1 and 2. In the similar way, we will put the markings on orange color cutouts as 1 and 2 and on red color cutout as 3 on both sides with the help of marker. Arrange the rectangular cutouts 1, 2 and 3 side by side and join their corresponding flaps by using glue. After this, place the triangular cutouts at the free sides of the rectangular cutout marked as 2 and join them by gluing their flaps together. At this stage, the 2D net for forming the triangular prism is ready. Now flip it over. Fold the rectangular cutouts 1 and 3 towards each other and join them by using glue. At last, fix the triangular cutouts towards the inner side of the model like this and join them by using glue. At this stage, our triangular prism is ready. Take out the 2 pentagonal cutouts, 3 orange colored rectangular cutouts, 2 red color rectangular cutouts, marker and glue. Now fold the rectangular cutouts along these white lines as done for triangular prism. Now put the markings on the pentagonal cutouts as 1 and 2, on orange color rectangular cutouts as 1, 3 and 5 and on red color rectangular cutouts as 2 and 4 with the help of marker like this. Arrange the rectangular cutout 1, 2, 3, 4 and 5 along the 5 sides of pentagonal cutout marked as 1 and join their sides by using glue. After this, place the pentagonal cutout marked as 2 at the free side of the rectangular cutout marked as 5 and join them by using glue. At this stage, the 2D net for forming the pentagonal prism is ready. Now flip it over. Fold the rectangular cutouts marked as 1 and 5 towards each other and join their flaps by using glue. Now fold the pentagonal cutout marked as 2 and join the free flap of rectangular cutout marked as 1 on it, like this. Similarly, you need to join the rectangular cutout marked as 2 and 1 together, then rectangular cutout marked as 3 and 2 together, and so on. At this stage, our pentagonal prism model is ready. In the similar manner, you can perform the activity to form different types of prism such as rectangular prism, hexagonal prism, etc. The relationship between the number of faces, edges and vertices plays a very important role while designing the prism shaped simple products and buildings. Take out the triangular prism model and pentagonal prism model that you have prepared. Euler's formula shows the relationship between the number of faces, edges and vertices that a polyhedron does have. F plus V minus E is equals to 2, where F is equal to the number of faces, V is equal to the number of vertices and E is equal to the number of edges. This formula states that if we subtract the number of edges from the sum of the number of faces and vertices of a polyhedron, then the difference will always be equal to 2. Now, let us verify the results which we have got for triangular prism. It has 1, 2, 3 rectangular faces, 1 and 2 triangular faces. Similarly, we'll check the number of edges. It has 1, 2, 3, 4, 5 and 6, 7, 8 and 9 edges, and it has 1, 2, 3, 4, 5 and 6 vertices. Now we will apply the Euler's formula. For triangular prism, it has 5 faces, 9 edges and 6 vertices. Therefore, F plus V minus E is equal to 5 plus 6 minus 9, which is equal to 11 minus 9, that is 2. As the difference equal to 2, the formula is true for triangular prism. Now let us verify the results we got for pentagonal prism. Here it has 1, 2, 3, 4, 5 rectangular faces, 1 and 2 pentagonal faces. Similarly, we can find out the number of edges it has. Here it has 1, 2, 3, 4, 5, then 1, 2, 3, 4 and 5, and similarly 1, 2, 3, 4 and 5. So there are total 15 edges and it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 vertices. For pentagonal prism, it has 7 faces, 15 edges and 10 vertices. Therefore, F plus V minus E is equal to 7 plus 10 minus 15, which is equal to 17 minus 15, that is 2. As the difference is equal to 2, the formula is true for pentagonal prism. A prism is a 3D model with different type of shapes. So, the way a prism looks like from different angles may or may not be the same. Now, we will find out the top view, front view and the side view of the different prism models that we have created. These drawings are helpful to form the two-dimensional nets of the polyhedrons, which are widely used in designing industry for making new products. Again, take out the triangular prism model and the pentagonal prism model that you have prepared. Take the triangular prism model to the front of the table and then stand up and look at it. This view is called the top view of the model. Now, sit down on a chair while facing towards the model such that it is at your eye level. This view is called the front view of the triangular prism. At last, while sitting in the same position on the chair, tilt your head towards the right side or the left side and look at the side of the model. This view is called the side view of the triangular prism. After doing this, put back the model on the side of the table and take out the pentagonal prism. Put the pentagonal prism to the front of the table and then stand up and look down towards it. This view is called the top view of the model. Now sit down on a chair while facing towards the model such that it is at your eye level. This view is called the front view of the pentagonal prism. At last, while sitting in the same position on the chair, tilt your head towards the right side or the left side and look at the side of the model. This view is called the side view of the pentagonal prism. In the similar way, we can perform the activity to visualize the front, top and side view of different prism models and identify the difference between the shape from different angles. Hope you have enjoyed it. We are sure that after performing this activity, you will have gained the expertise in the following concepts: preparing the two-dimensional nets to form the three-dimensional prism model with different polygonal bases and observing the number of faces, edges and vertices it has. Verifying the relationship between the number of faces, edges and vertices that a polyhedron does have, or the Euler's formula for polyhedrons. Observing the prism models with different polygonal bases from front view, top view and side view to understand how they look different from different angles. Visualize maths with Allen IntelliBrain and fall in love with learning.